Hello everyone, welcome back to the one more session of multimedia systems. In the sessions we were discussing about the topic called optical storage media. Okay, in the previous session we had discussed about the CD-ROM based development. So the various developments that's been involved in the CD-ROM technology, and we have also discussed about the compact disc interactive, what we call it as CDI. Next we had discussed about the audio coding of compact disc interactive, that is audio coding with respect to CDI. Also we had discussed about the coding of images of CDDI, in which we had discussed about the YUV, CULT, that is color lookup table format, and also the RGB format. And we had discussed about a bit of coding of animations with respect to CDI. And finally we had discussed about the compact disc interactive ready format, the importance of it, and all these things was discussed. Now let us look into the one more technique, we call it as compact disc bridge disc. Let us look into this, that we call it as compact disc, and it is also called as with respect to the bridge disc. Why it is called so? Let us look into the details of it. Like CDDI disc, but the original goal of compact disc bridge disc is to reach or enable the CDI to the output devices supporting to the different formats, whereas earlier disc the CDI was very specific to one particular format, whereas the CDI with respect to the compact disc with a bridge disc, the main intention or goal is to enable the CD devices so that it can be used to output on various different formats and all feasible devices. Second one, CDI ready disc, that is CDI. We have discussed about the previous session. CDI ready disc specify disc formats, means it has a predefined format which allows output either on a CDDA technology devices or CDI technology. Means you should be very clear, the compact disc ready format CDs can be played only on devices which are compatible with the CDDA technology or the CDI devices, whereas this one CD bridge disc is very much feasible with respect to the format that allow the output either on CD-ROM extended architecture or CDI device also. Means this compact disc supports the devices of CDDA with respect to CD-ROM XA architecture and also CD-ROM I, that is CDI devices. So this device can be played on both the devices. Why is that so? Because it allows the Form 2 specifications, whereas CD-ROM XA is always supported with mode 2 of Form 1 and Form 2. Here this is also using the same kind of specification. We do not need to go to the Form and Form 2 technology. Why it is so, and all these things? Because we have discussed mode 1, mode 2 of CD, mode 2 Form 1, mode 2 Form 2, and all the forms of the CD-ROM XA in the previous session itself. Next, CDDI bridge, that is CD bridge, we can call it as CD bridge disc, is specified with both CDI and CD-ROM XA specification. Means this technology make use of these both specifications. Means this bridge disc is the composition of these two specifications, that is the CD-ROM XA specifications and CDI specification. That's why it supports though both devices which are supporting CD-ROM XA CDs to be played and also the CDDI devices to be played are supported with the CD bridge disc. Means it is acting as a bridge between these two technologies. That's why this is called the CD bridge disc. And one more important thing that we need to look into here is all the track with the computer data must be recorded using CD-ROM mode 2 only. Here it supposed, that's why I told you earlier, with respect to CD-ROM. Here in the specification of Cddi Bridge, all the data, or when we talk about data, computer data, must be stored only in the format that is supported to CD-ROM mode 2. When we say about CD-ROM mode 2, obviously it is supported by CD-ROM XA technology. Let us look into the diagram that explains very clearly about the compact disc bridge one. So earlier, when we started talking about the technology, it was the first thing we saw was the CD-ROM. So what does CD-ROM does? CD-ROM has a combination or associated information from the Cddi. Means it has been derived the specification and it has lot more similar properties or specification with respect to CD-ROM and Cddi. That's why we call it as mixed mode disk. So CD-ROM also supports this and Cddi also supports this. So these two combination is called mixed disk. And after this we have come across the Cddi, that is CD interactive. We have saw the specification, we have seen the details, tracks and how all these things is done. And how is this done? We call this as Cddi ready disk. Again, there is a combination or the link between Cdi and Cddi. Look at this. Means what is that? There is always a bridging of the things, means there is a link between one another. Now what we do? So we have come across from Cddi with respect to CD-ROM, from Cddi with respect to Cdi. But what does we do? From Cdi we have come across the new technology, that is CD-ROM XA. That is CD-ROM extended architecture. We have thoroughly gone through the CD-ROM mode 2 form 1 of XA, CD-ROM XA with respect to mode 2 form 2. You should recall those specifications when we talk about CD-ROM XA. Then what is that bridge disk do? Now bridge disk do the linking. Look at this. This is how there is a bridging of the technology. Means now we have seen. So when we talk about a mixed mode, it is bridging the CD-ROM with respect to Cddi, and when we talk about Cddi with respect to Cdi ready disk, that is we have seen in the previous session itself, Cddi interactive ready format, so which is a bridging of things. Now we have a bridging of Cdi with respect to CD-ROM XA. So this kind of disk which has a intermediate property or which has both specifications with respect to Cdi and CD-ROM XA, we call it as CD bridge disk. The compact disk for the output on the devices with multiple formats is represented. So we have seen about mode 1 of disk, Cdi ready disk and CD-ROM disk. So this is how we represent the bridging of various disks. We call this as CD bridge disk. Are you clear? Next. The next topic we are about to see is the photo compact disc. Now we have seen about various technologies with CD-ROM. So this is the next one. This was developed by Eastman. Eastman Kodak. You might be very familiar with this word Kodak with respect to photography, the films, the Kodak studios, etc. And the well-known person N.V. Phillips. So this photo compact disc was originally developed by these two brilliant persons. One is the Eastman Kodak and second one is the N.V. Phillips. So you know that the contribution of N.V. Phillips till now, he has contributed to almost all the developments of the technology with respect to CD. Next, why is this technology came into picture? This technology was mainly used or developed for storing high quality photographs. Store very high. We can say it as that's why you might have seen when you are talking about the film rolls, studios and all things, the Kodak studios, the Kodak cameras, the Kodak film rooms, the same technology by the same person was extended throughout the world. It had become so popular, the photo compact disc technology, that was also incorporated in films, devices and everywhere. It has become so popular, you might be knowing all these things. So the main intention of this technology was to provide a huge storage with respect to very high quality of photograph. Then photo CD is based on CDWO. What is WO? We have already discussed about the W, that is write once. Means there is already predefined format on which you can write your data on the CD only once. That was the technology that was used. And the next part is this CD was delivered already written, and the second part was only was available to write by the end users. Means when you talk about write once, there should be already predetermined format with the CD. Means the company you would have set the tracks, sectors, the initial point and everything. So initial writing of the CD would have been already written by the manufacturers. Only the second part was left alone for the end users to write. So what was the things? So the person who bought this compact CD would have the option of writing it for the second time. Means he can write it on the predefined or a ready format that was given by the company. Already they had made the writing place ready, and these people, end users, could have written or burned their information on the CD only once. So, but they can have the property of retrieving it as many times or viewing the contents or retrieving the information from the CD many times, but writing was permitted only once. That's why they made use of the concept called CDWO, that is write once. So can either the CDI or CD devices, means this can be used by this kind of CDs can be used by the devices supported by CDI or CD-ROM XA devices. Means photo CDs can be read or burnt using the devices that were supported by these things, and also it can be read or written by the earlier devices that was manufactured by CDWO technology. Means write once. Even with those devices, these CDs can have been was supported by with respect to the reading of information, and also it can be written only once. That was about the photo compact disc. And looking into the photo CD based processes. This was just an introduction with respect to the photo CD. Let us look into the process. What are the different processes that is involved? This photo, when you know that photographs are created using the conventional camera and the films, means, so we take I am talking with respect to very conventional way of, now I am not talking about the today's trend, okay. So how was the photographs created? They were clicked with the cameras, that is photograph conventional cameras, where the films was used. You might have seen that black film coated films was used, and after the film was developed, means those films need to go into the dark room and it needs to be developed with respect to a specific technology. After the films were developed, these pictures are digitized using a resolution of 8-bit. Means first, photos needs to be captured on the films. Second, it needs to be digitized using 8 bits of resolution. What is the importance of 8 bits? Here they supported 8 bits for luminance. There are two components. In the previous session we have discussed, when you talk about the images and the coding of images, two main components come up. One is the luminance and second one is chrominance. So these two are the very important components. So very important components with respect to of photographs. So when you talk about luminance, it is about the light, and when we talk about the chrominance, it is about the color. Now when we talk about the digitization, 8 bits of resolution supports digitization with 8 bits of luminance components and 8 bits of chrominance components. When we talk about chrominance component, we have seen that is Y, U and V, where Y is for luminance component and UV are said to be the chrominance component. So each component were supported with the 8 bits, 8, 8 and 8. So this is the importance. So when each bit is been given the preference of 8 bits, so we get 8 into 8 into 8, that is 24 bits. That is why we are able to achieve high quality images in the photo CD, or it supports the storing of very good high quality images. So that's why the importance of photo CD process was involved. And also each photo is then coded up to 6 resolution as an image pack. So each photo is coded with 6 resolution of image pack. What is this image pack? This image pack requires 3 to 6 megabytes of storage. It requires almost on an average we are talking about 3 to 6 megabytes of storage, depending on the complexity of the image. Means when you talk about an image, there would be some images would be having very high chrominance and some would be having very low chrominance, and some with respect to a chrominance variation, all these things. So based on the complexity of image, this image pack, that the image is stored in the form of image pack with 3 to 6 megabytes of information. Next, the integration of photos with the digital computer and television technology enables the new professional. Now, what is the importance of this? We saw about the process. How does this technology mean providing its importance to the current trend? We see that. So integration means combining these photos, that is photos from the photo compact disc with the digitized computer, because it is been digitized now. We have seen how the digitization happens. So the photos from the photo compact disc, when we talk about the digitization with the computer and the television, it enables new professionalism, means it is giving a new jobs, new trend, and the new consumer applications also, where the animation concept, moving of images, sliding of images, so merging of images, all these concepts were coming up. So that gave up a concept or a profession called animation technology also. So it was also supported with the end user applications. So end users were given with the different kinds of applications, so that end users feels or comfortable or he can enjoy those photography. And using different resolution, a digital zoom feature can also be implemented. Now look at this. This is one of the important parameter here. Till now we were able to store the images, quite right. Second one, we were able to view that images, but we were not able to zoom that images. Now with this technology, with a very high intensity and high quality of storages images with different resolution, means here with the photo compact disc we were also allowed to store the images based on the requirement or our wish with respect to different resolutions. So we can zoom the images, means enhance the images, go in deep with respect to view of the images. And also multiple images can be displayed in an overview presentation by lowering the resolution, means so on one image, one more image can be overlapped by lowering the resolution. You might have seen this kind of features even in the PowerPoint. We overlap by reducing the resolution of one image, we send it to background and we overlap it with other images. So this was also supported with respect to the compact disc. And finally, when you talk about this, there were new softwares coming up where images can be modified after the fact, that it can be inserted into documents also. Means to insert those, taking that images, and that can be incorporated or inserted into a document through various softwares. Those different softwares came into existence. These were the things about the compact disc with respect to the photo. We call it as photo compact disc. Next, let us look into the next concept. This is a lengthier title called digital video interactive and the name itself suggests the complete description, and commodore dynamic tool vision. And Commodore Dynamic Tool Vision. Now look at this. What is this? This is the new technology after the photo CD. So here we are talking about, because in a photo CD we saw about the process of digitization. So from here, from the photo CD onwards, everything started with respect to complete talking about the digitization. So when we talk about digitization, it supposed various software with respect to compression, decompression, and lot of modifications that can be achieved once the things are completely digitized. So we look into the concept. So digital video interactive, we call it as DVI. So digital video interactive, we call it as DVI devices. So it is something which uses the specifications like that of CDI. So you know that. So what is the importance of CDI interactive, that is CDI? So most of the specifications that of CDI was derived or used with the DVI, that is digital video interactive. So then when looking into the DVI, it consists of both compression and decompression algorithms. means it adopted a very good techniques or algorithms for both compression and decompression. These kinds of algorithms were highly integrated into this DVI, and dedicated hardware components for compression and decompression for videos in the real time was supported. Means dedicated hardware was given particularly for the video with respect to the compression and decompression for using suitable algorithms. So particular device specific hardware was used with respect to DVI. DVI uses the CD-ROM mode 1 technology. Mode 1 with respect to the blocks, we have seen how the blocks are bifurcated, means how the information are segregated when we talk about CD-ROM mode 1. So same kind of concept with respect to the splitting of information with respect to bits. So that is being used as per the standard format of CD-ROM mode 1, and also it supports the ISO 9600 format, because it is a standard one. When it is say about CD-ROM, always say CD-ROM mode 1 supports ISO 9600. When most of the things has been derived from the CD-ROM, obviously it has to support 9600 format for the basis of AVSS. What is AVSS? AVSS means audio video support system. Why do we call it as audio video support system with respect to the ISO 9600? Because the information here are stored in the interleaved. You might see that when you look into the CD plate like this, horizontally you see the track. There would be ups and downs, means there is ups and lands on this. So these data in between, so interleaved format data has been stored. So it supports that format where the damage or the loss of information is very much negligible, or in other way it is a one more technique to protect the information. We can convey it in this format. Next, DVI other restrictions was what this is about the DVI. Then what were the particular restrictions? This DVI format had a lot of restrictions into it, means it had a specific type of file names to be stored, and it was limited up to 8.3 characters. We call it like this itself, 8.3 characters. So this was very hard to code it. When we talk about coding, retrieving of information was also difficult, and this type of devices were not supported with respect to other things. If that DVI device was to be played with other devices, it was not supported because it has the 8.3 characteristics of coding restrictions with respect to the file name. So it started losing its popularity. So this was the main constraint. We can call it as drawback of a CDI. So that was the thing where people found it to be very difficult with respect to the compatibility with respect to other devices. Whereas when you look into the photo CD, it was very much compatible with respect to CDI and CD-ROM XI devices, and it was also been very much compatible with respect to CDW or write-once devices. Whereas this DVI was very much improved version, but still it has a compatibility issues. So because of this, today till that after that invention, neither system had more commercially popularized. Means the commercial popularization was very negligible, and people gave up less significance, and totally the popularity went down. So and people did not like that device, and the production is so very much early it was stopped because of the compatibility issues. Next, continuing with the things, the next technology is compact disc recordable. This is the most interesting one, and still we are making use of it. We call this as CDR. So now if you go to any of the shops and ask, give us a CD which we can write data on it, you might have seen this. The brand name would be different, like Sony, Samsung, HP, different names, but on that they have written CDR. What does R stands for? R stands for recordable, that is compact disc recordable. All the technologies when you talk about CDs are to be considered till now do not allow users to write to the disk repeatedly except the photo CD. Means they do not allow multiple writing. Okay, so that would allow only once. We call it as write once, except photo CDs to some extent. So the new technology need to be emerged in order to overcome this one. So research labs throughout the world started to work on the CDs that can be written not only once or multiple times. Means CDs that's supposed to write once, also many times on it. Means multiple data recordings was required on that compact disc. So people and the many research labs started working on this. Means photo CD was able to give up a write once, means only once. So user was able to write once, but they wanted to have the multiple writing sessions on it. So this was the new technology that gave rise when the researchers started working on it. So when I talk about a CDR, that is compact disc recordable, it is something like worm, which we have already discussed. When we talked about the different kinds of CD-ROM technology long back, that is write once, read many times. Write once, read many times. Means those data can be written once on that CD and it can be read as many times as user wants. That means that allows the users to write on the CD once and he can view the contents or read the contents or retrieve the data that's on the CD for many times. So this is about the compact disc recordable. So how does this compact disc recordable work? Let us look into the principle of the working of CDR. Now we have already seen the diagram. First, when I talk about the CD, the cross-sectional view, there would be label. Okay. After the label, there would be one more layer. We call it as the protective layer. When you talk about the cross section of a CD, okay, the topmost would be label. After that, there will be a protective layer. Below that, there would be a reflective layer. I have told you or explained you the importance of each layers in the CD-ROM technology, working of the CD technology itself. The same principles holds good here also. So the importance of reflection layer here is, so we know that when the laser beams are protruded here from the down, so it should not cross beyond it. It has to get reflected here, bounce back, so that we can retrieve the data or read the data. That is the importance of reflective layer. Now we have the pitch and lance. Okay, so when you talk about pitch and lance, these are pre-engraved here. Look at this. This is a very important when you talk about the difference between the CD technology and the CDR technology. So we have seen and pitch and lance there also, but before the pitch and lance, what would be there? There would be a substrate layer. What kind of substrate layer? It's a polycarbonate substrate layer will be there. But whereas here we have pre-engraved, means these are the pitch and the lance. Pitch and lance are pre-engraved here. So with the absorption layer. So in a CDR we have a pre-engraved pits and lands with respect to the CDR, and we have absorption layer, whereas in the CD we have the substrate layer, that is polycarbonate substrate will be there on which the information would be stored. Here we have pre-engraved pit and lands where the information can be put on that space. That is the importance of the CDR. Let us look into it in detail. So this figure clearly shows the sectional views. Now, so CDR as pre-engraved tracks. What are those tracks? Are nothing but the combination of pits and lands. All the CDs, as I already said, okay, when you talk about CDs, have polycarbonate substrate that adjoins the reflective layer. Means look at this reflective layer. So in CDs have the polycarbonate substrate layer with adjoins or with matches or joins the reflective layer. But what happens here in CDR? An absorption layer is given between the substrate layer and the reflective layer. Means look at this. The below substrate layer is there, then the absorption layer here between the substrate reflection layer and the substrate layer. This is the importance of the layer. As I said, this is the region where the manufacturers have given the option for the users to put their data or write their data. So a strong heat has an effect of irreversibly modifying this layer by reflecting with respect to the properties of laser light. Means a strong heat, you know that the property of laser light, it has very high intensity laser lights. So these layers with the heat makes the absorption layer engrave the information into those pits and lands. Using the laser with the intensity 4 times greater than the CD-ROM technology. So here with respect to CDR technology, even it uses the laser light properties, but the intensity of the laser light used here in CD-ROM is with CDR is 4 times greater than the conventional CD-ROM technology. So and also the pre-engraved tracks is heated to above 250 degree centigrade. This is to be noted. So when we want to have such a high heated intensity of laser light, we need to look the difference between the absorption layer, or this absorption layer only absorbs the data with the laser which is 4 times with more intensity compared to the CD-ROM with 250 degrees centigrade, only then it works with respect of storing of information. And this is with respect to the alters the materials. Means this heat of laser light changes the materials such that the reflected light now corresponds to the pit. Means so this absorption material pushes the data and puts into the pits. This gives rise to the property of CDR, so that we can write it on the pre-engraved pits and land. This is how the CDR works. Now with this diagram you are very much clear how the CD-ROM R works. Next, when you talk about the CD-ROM, there is one more problem we will see into this. And how can we overcome this problem? That is with respect to sessions. Now all CDs have lead in area and lead out. Okay, we have 2 things, that is lead in and lead out. Lead in precedes the actual data. Means if data is here, lead in will be here and lead out will be here. So this would be a actual data. So of each track, what does this lead in and lead out contain? Lead in area holds the table of contents which are needed by the entire block devices. Lead in contains all the information, that is something like an index. When we write in a book or something, it's like the index. It holds all the data for the playback devices. Means if a device wants to play, so what and all the information that is present, it is been stored. That is like an index, it is stored in the lead in area. Then what is about the lead back? lead out. Lead out stores the information stating that this is the end of that track. This is about lead in and lead out. Now, what happens during the process of a CDR? When writing a CDR, this area cannot be written on the disk until after the write procedure has finished. Means when we are writing something onto the CDR, because we have initiated the lead in already. So still we are writing a process. So lead out has been not finished. So during this period, the data already present in the CD cannot be read. So this was the problem. So though we are not touching the already stored data, we are storing some other information, but yet we were not able to retrieve the information that has been already stored, because we have already accessed the lead in information. Lead out has been not given up. So that's why this was the problem. So when we are trying to put the data, it was something like copy to disk in one atomic action. Means at one shot it was required, means only one lead and only one lead out was there. So whatever we want to put into the data, at one shot we were supposed to put. So if you think that again, if you wanted to add up somewhere the later, it was not possible. So because that session would have been expired. So this was the problem. Meanwhile, there were a lot of other devices which were not able to read such kind of data when lead in lead out was occurring. To solve this problem, so multiple sessions were introduced. So we know that this problem, this session lead in and lead out, to overcome this, they thought, why not we come up with a multiple sessions, because each session would have been accessed independently. So they thought, so particular track and particular sessions were allocated to one thing. So while we are doing with one session, the other sessions were of data and other tracks were totally independent. So whoever wanted the information, whatever the information that was needed, can be accessed without any interruption. So that's what the concept they introduced. How does this session work? Let us look into it. So they thought, why not we have the like this, lead in, information, lead out. Look at this, lead in, information and lead out, and this was session 1. And subsequently there could have been one more session. Lead in, information, lead out. And this could be the second session. And this might go on. Okay, this might go on to n number of sessions. So when we wanted to have access on particular session, there was no issues. The other session could have been concurrently read or written. So this, by using this multiple session, the problem that we saw earlier were able to overcome. So these were the things that I had wished to discuss in this session. While summarizing what we have discussed in this session, first we have seen about the compact disc, bridge disc. How does the bridging happens with respect to various technology? We have seen the compact disc with respect to photo. We call it as photo compact disc, which use the technology of CDWO, that is write once. With the photo CD based processes we have seen, how does a photo CD is being processed, that is from film to digitization, and also with respect to conventional TV and the other technologies. Later we saw about the digital video interactive and also commode with respect to dynamic total vision. And later we came up to the new technology that's been still been prevailed, that is compact disc recordable. So we saw the working principle of the CDR, and finally we have seen the different problems that we encountered with respect to accessing, with respect to lead and lead out, and the solution was the multiple sessions using in the CDR technology. So these were the things I had wished to discuss in this session. Thank you very much.